This video is going to cover 7.4, the trapezoid. So a trapezoid is a quadrilateral with two parallel sides. This is how we're going to label it. I'm going to go ahead and just identify the vertices with the capital letters A, B, C, and D. And earlier I said it was two parallel sides. Let me go ahead and say two parallel bases, because this base is going to be parallel to this base. These are my bases. Halfway is our mid-segment. And that's found by taking the average of the two bases. And then each of these slanted sides is called a leg. Base angles, if your trapezoid is an isosceles trapezoid, will be congruent. There's nothing marked on this one, so I can't assume that it's isosceles, but if it did say it was isosceles, then we would know that these base angles would be congruent. All right, so properties of a trapezoid. The first thing is we have two parallel bases. Two pairs of consecutive angles are supplementary. And I want to identify, that would be like A and D, those are supplementary, and B and C are supplementary, but not A and B, not in this order. They have to be the angles that are attached to the legs. So I'm going to write on here, angle A and angle D add up to 180, supplementary. Angle B and angle C add up to 180. And you know, instead of putting a little and, let me just say plus, because that's what we're doing. We're adding to 180. And the diagonals have no relationship unless it's isosceles. So earlier I said the mid-segment of a trapezoid, this is the segment between the midpoints of the legs. All right, so here's my midpoint of one leg, and here's my midpoint, and that is the mid-segment between these two midpoints. And the mid-segment is parallel to the base. So let me go ahead and put a little parallel line. So the mid-segment is parallel to the base, the bases. And it is the mid-segment is equal to the average. I'll write the word out. Of the two bases. So now an isosceles trapezoid is a trapezoid with equal base angles. Opposite sides are equal. And I'm talking about the legs. The base angles are equal, they're congruent. And the diagonals are congruent. Okay, so let's take a look at example 1. It's asking us for the measure of angle B. So my bases in this problem are these two, the guys that are parallel. So I know that consecutive angles are supplementary. And so angle B plus angle C add up to 180. Now this is just a trapezoid that's just been kind of tilted on its side, but that doesn't matter. I can just subtract the 67 from 180, and I'm going to get 113 for the measure of angle B. These consecutive angles are supplementary. Okay, so what else do we know? Let's find the measure of angle D now. All right, so I can use that same property to find the measure of angle D if I know the measure of angle A, because these two angles are also supplementary. So 180 minus 103, and what is that going to give us? 77, and that's the measure of angle D. Okay, in example 2, okay, so what this is showing us is it's giving us that the mid segment is 13. That is the average of these two bases. And so we know that x plus 17 divided by 2, because that's how you find an average. You add up the two numbers and divide by the number, equals 13. So in order to get the x by itself, I'm going to multiply both sides by 2, and that will give me x plus 17 is equal to 26. And if I take away 17, x should give us 9. Okay, in this next example, this time we're finding the mid-segment, and it's just the average of these two bases. So let's add those two bases, divide by 2. And I believe that's, what, 11 over 2, which is 5.5. All right, so same thing, this time just with some algebra involved. Add up the bases. Okay, I'm adding up this guy and this guy. Divided by 2, it's going to equal the mid-segment. So x plus 11 plus 9 divided by 2, that would be the average of the two bases, is equal to x minus 20. All right, so let's see. In the numerator of the fraction on the left, let's see, 11 and 9 is 20. So x plus 20 over 2 is equal to x minus 20. I'm going to multiply both sides by 2 to get rid of that denominator. So I've got x plus 20 is equal to 2x, and I should put this in parentheses, minus 40. You need to distribute to both of those guys. Well, now I just have some algebra to do. Let's subtract x and add 40 to both sides. So this is 60 is equal to x. So I know my x is 60, and now if I plug in 60 to each of these x's, that's going to give you 71 for AB. And let's see, if I plug in 60 for here, 60 minus 20 is what, 40? All right, and that one's done. Example 4. What's us to find the measure of angle A? Okay, so now this is one of the isosceles trapezoids, and we know it's isosceles because it's got the little marks on the sides. And so I know base angles are congruent. This is 42. I know that consecutive angles are supplementary. And so if I add these two together, that's going to equal 180. Or if I just subtract 42 from 180, let's see, what is that going to give me? 138. So I know that measure of angle A is 138. The measure of angle B is going to be, well, 138 also, because its base angle is 42 and supplementary. And the measure of angle C, well, I had already figured that. That was 42. And that's because it's an isosceles trapezoid. Those are fairly nice. Okay, so another isosceles trapezoid, I know that base angles are congruent. So 3x minus 5 is equal to x plus 7. Let's just do the algebra. Solve for x. So this is 2x is equal to 12, and x is equal to 6 if I divide both sides by 2. So my base angles, if I plug in a 6 right here, 6 plus 7, this is 13. So the measure of angle D is 13 degrees. And if I want to find the measure of angle A, well, I know that angle D is also 13, because the measure of angle C, those are congruent. If I'm going to find the measure of angle A, this will be supplementary to the 13. So 180 minus 13 is 167. 167 degrees. And then, well, BC, if I want to find that side, it's congruent to 8x. And if I know my x value is 6, then if I plug in the x there, 8 times 6, that gives you 48. Last example, example 6. Okay, so we have another isosceles trapezoid. We know that AE is equal to 2x. Okay, so let's review an isosceles trapezoid. Opposite sides are congruent. Base angles are congruent, and the diagonals are congruent. Okay, so we know that EC is 3x. So this diagonal here, 2x and 3x, is equal to 5x. That's what that length of the diagonal is. And then we also know that DB, that's the other diagonal, is equal to 30. So I know that 5x is equal to 30, and so if I divide both sides by 5, x is equal to 6. And I think we're done with our trapezoid notes.